All right, so this thing is a little bit imposing, isn't it? They want us to simplify this. Well, okay, we'll do the same drills that we normally do and trust that they're going to work. This is two great big fractions, and our procedure is we're going to factor every single piece of this if we can. And we're going to hope along the way that some of the factors that we produce will cancel each other so that the thing simplifies down. If nothing cancels, then we'll be sad, and then we will stop and say it cannot be simplified. But generally in these workbook problems, we get a fair bit of reduction, a fair bit of simplification that we can do. So, top left, this is a trinomial. It has no coefficient, or it has a 1 coefficient on the a squared. So we're looking for two numbers which add up to 8, multiplied to 15. That's easy enough, 3 and 5. Hope they all go that easy. Downstairs. Oh, they're not that easy. This, we're going to need, well, where do you think we should start if we're factoring this? What's the first thing you look for when you're factoring anything?
Well, good luck.
I hope you're not thinking numbers that add up to 21 and multiply to 54, because the first thing that should happen is this has a common factor of 3 in it. The very first thing you should do is haul out that 3. That'll leave you with 2a squared plus 7a plus 3. And now that's going to make the decomposition easier. I'll get back to that in the next line. This top thing contains a common factor of a. Take that out and you're left with 1 minus 4a squared. And there are no common factors in this one, so I'm more or less stuck with it. Okay, so common factors are done. We got this one in the top left done because it was easy. Now, these two in the denominator are a little tougher to factor. I'm going to need decomposition to handle both of those. I'm going to do it kind of in short, abbreviated form because I don't have unlimited space. But by all means, copy this to a separate page and reassure yourself that I'm doing everything right. Here I need two numbers which add up to 7 and multiply to 6. Those will be 6 and 1. So my rewrite is 2a squared plus 6a plus a plus 3. Factor the first two and you get this. Second pair, all I can factor out is a 1, and I get a plus 3. So my finished factorization is a plus 3 to a plus 1. That's what decomposition looks like when you do it a little bit too fast. 2a plus 1. Now, up here, top right, we took out a, and that was good. This is a difference of squares. 1 is a perfect square, and so is 4a squared, so we can take this down even further. The 1 would have come from 1 times 1, of course. The 4a squared would have come from 2a times 2a. And in the bottom right, more decomposition. I'm just going to erase this first one because I need the space. All right, so we need two numbers which add up to 9 and multiply to negative 10. That should be 10 and negative 1. 2a squared plus 10a minus 1a minus 5. Factor the first two, we can take out a 2a and we get this. For the second two, I can factor out a negative 1. I get a plus 5 again. That's what we like to see. So a plus 5, 2a minus 1. Again, there should be lots of practice in previous units if you need to review decomposition. I'm blazing through it here because it's not the focus for this question. I'm assuming that you're more or less comfortable with it. If you're really uncomfortable with it, please get a hold of the tutors or the teacher will be happy to get you up to speed because decomposition is great. Okay, this is all factored. Now, did it pay off? Well, here's something. We have a plus 3 over a plus 3. I see an a plus 5 and an a plus 5. Is there anything else? There are two other things. One of them is hidden a little bit, and the other one is hidden quite a lot. The slightly hidden thing is 1 plus 2a is exactly the same as 2a plus 1. We can scratch those out with no trouble at all. Can we cancel these? We can't right now. This is a positive 1 and a negative 2a. This one has the signs the other way around. So at the moment we can't cancel those, but I'm just going to rewrite that and then we'll take another look at it.
7.
a 1 minus 2a
Amazing.
over 2a minus 1. You can't cancel these the way they are, but we have a trick precisely for cases like this. You remember? If we factor a negative 1 out of, well, either one of these, but I normally do it from the numerator, here's what happens. Out comes our negative 1, and we get negative 2a divided by negative 1 is positive 2a. 1 divided by negative 1 is negative 1. And then we have our denominator, and look at that.
Oh.
Now they match. Now we can cancel them. So when you have binomials like this, which are almost there, except that the signs are backwards, factoring out a negative 1 is usually what you need to match them up. And then you cancel them. And now we're left with a times negative 1. And the nicest way to write that is just negative a, or minus 1a if you prefer. So we simplified the snot out of this. That's good. The next thing they wanted was non-permissible values, which means we go back to this version before we have canceled anything, and we should be able to get one non-permissible value out of each of these factors. And I'm going to go through these quickly because we've had a great deal of practice here. From here we'll get a must not be negative 3. From here we get a must not be negative 1/2. From here we get a must not be negative 5. And from this one we get a must not be positive 1/2. So 4 different non-permissible values.